This is 4 on 7-1. Okay, so 4, you ready?
Yeah.
Does x squared plus 4 equal 0? 1. Find the number of complex roots. Complex roots, this is x squared plus 4 equals 0. How many solutions can there be? 2. There are 2 solutions. Guaranteed. Done. Next question is find them. How do you find them? You could factor. Do you know how to factor x squared plus 4?
Probably not.
I'd be impressed if you could. There is a way to do it, but it's not the way I would recommend doing this problem. So here's the way I would do the problem, is I'd move the 4 over to the other side, okay? Now we get x squared equals -4. And then I got to take the square root of both sides, plus or minus, right? So I get x equals plus or minus, what's the square root of -4? 2i. Right? Is the negative one there?
Yeah.
So there's 2 imaginary solutions. That's interesting. Now you guys think that means there's not real, it means there's no solutions at all? There are. There's 2 solutions. They're just happening to both be imaginary or complex. Okay, so now I'm going to graph my graph. Now for those of you who struggle at graphing, I suspect you should start working and getting over it, but if you don't, you should remember a parabola looks like what, generally speaking? I shouldn't say parabola. X squared graph looks like what, generally speaking? Right? Okay. And the only shift for it is up 4, correct?
Yeah.
Do you remember this? Y equals x squared plus 4. This is shift up 4, right? So I go 1, 2, 3, 4, and I go, woo! That's what my graph sketch looks like. So how many times did that cross 0? None. Why are the solutions imaginary? Because it doesn't cross 0. There's no real number where it's going to give you an actual answer. Does that make sense? Okay. I graphed it. I graphed it. No zeros there. But I expected that because I had imaginary solutions, right? Okay. Wait.
Oh, it's a y. So it's 4 equals x squared plus 4. And it was
No. Yeah? You good now? I gotta get my y's better. That's what the third person has asked me that question so far. It's good. No, I'm not making good y's. Not making good y's and not making good y's. Okay, try number 5. Start to sweat. Feel the burn.
Do we make a lot of money? How much do you get paid for your president?
The president is paid $400,000 a year.
Really? That's more than a surgeon.
It's
more than a heart surgeon.
It's more than most surgeons.
No, like the heart surgeons get paid $330,000.
All right. Moving around the room. Next. Guide me through this little job. Number 1. How many solutions?
You agree with me?
Sorry, number 5. What's the first question is how many solutions? How many steps? There are 2 solutions. Guaranteed. There's something weird about these solutions, but we'll talk about it in a moment. Second thing, I gotta solve this thing. How do you solve a quadratic? How do you solve a quadratic? Foil it. Anti-foil it. Factor it?
Factor it, yeah.
So x plus 1 equals 0. So each of the factors equal to 0. I got x plus 1 equals 0 and x plus 1 equals 0. What? X equals -1 in this case and x equals -1 this way. Now note, although the solutions are the same, there are still 2 solutions, folks. This is interesting. Watch out for that. That can trip you. Later on, that's like a trick question that's going to come at you when we deal with these things in more depth.
It's another parabola.
X squared is going to be a parabola.
Nope.
At x equals -1. It hits it on the way. It hits it on the way down.
Plus on the opposite of the way.
And hits it on the way up. Oh, that must mean that this is the bottommost spot, right?
Wait, does it go to?
No. I just heard a great question back there. How do I know? Because this is my solution for the way down. That's my solution for the way up. So So if it hits at -1 on the way down and it has -1 on the way up, what the heck is it doing? Oh, it must just barely be touching it. The only way we can have one solution, right? If it goes lower, I have two. If it stays above it, I got none. What's the only way I can have one solution? If it touches on the way down and on the way up. Make sense? That's kind of weird. It's like a special case right at the beginning. Not a great choice. I had to change this worksheet someday. Dulce's not looking at a cell phone, is she? Collected 4 cell phones today. Today. I'm on my cell phone. I'm a cell phone rant today. I only had 3 periods. I have more cell phones this period so far. Okay. All right. That's it. That was I did that one. Okay, we're trying number 6. Number 6 is hard. Because you guys probably forgot how to do cubics. I don't think I got that.
Oh snap! All right, well I got that part of the puzzle.
So it's connected.
See, look, Brent. If this has to be, if this is true, and this row is 3, that means that the next dot has to be the one right above it. Which means that then it needs to turn right because there's nowhere else for it to go. So that's to go right there. So, anyway, what did you get? Yeah, okay, that's what I thought was gonna happen.
I knew it.
I suspect the majority of students have forgotten how to do these. That's why we're playing.
Oh yeah, in the middle one. Oh yeah.
All right.
Or does it? Because
Got it. We're gonna go. All right. I gotta factor this. Now, what people forget is the simplest way to factor is there anything I can take out of all these? Very Dana. So anything I can take out of all these? I can take an x out. So I can go x squared plus 2x minus 15 equals 0. Now, before I move on, I forgot to answer the first question. How many solutions am I going to get?
3.
3 solutions. There are 3 solutions to this. I need to find them. What? So now I'm going to factor.
it's another problem.
When I go to factor it, it is x plus 5, x minus 3. So my solutions are going to be where each of these little factors equals 0. So I get x equals 0, x plus 5 equals 0, and x minus 3 equals 0. Great?
Wait, how'd you get x equals 0? Oh, because you set the outside one.
I just
0.
said each factor equals 0.
Okay.
So x equals 0, that was already done. X equals -5, and x equals 3. Those are my solutions, right?
The graphing part, are we gonna, is this gonna be like on the non-calculator part?
The amount of graphing you have to do on this test is going to be pretty small, but understanding what the graphs are doing is going to become more important. And that's kind of what I'm going to get at right now. So follow on. What I'm doing now is important.
Okay.
The why, there's 3 solutions.
Okay.
Where those 3 solutions are, what does that mean? That's what we're dealing with here. So if I look at this, I go x equals 0 is one solution. X equals 3 is another solution. Equals 5 is another solution. So what's the shape of this graph? What's the shape of this graph?
Sine curve.
Yeah. There's my solutions. Something like that.
Why can't it go down?
It could. How would I check to see which one it's doing? Pick a really large number. A million. A million cubed is a million, million, million. Plus 2 times a million, million. Well, this is much bigger. Minus 15 million. Well, that's trivial compared to million, million, million. So it's going to be a positive number, right? It's going to be a very big positive number. So it needs to end over here. Well, I know these are only 3 solutions, right? So it's going to end here. It's going to come back through here. Can I make a U-turn?
Does it? Okay.
It's so weird they're not proportional.
Yeah.
They don't have to be proportional. There are going to be all sorts of weirdnesses going on.
Will you check for it? Like.
Again, I'm not going to make you graph much on this test. It really is not a graphing test. What's more important is that you need to realize that the function is going to start someplace. It's going to get closer to 0 as a solution, and then it's going to go past that point. It's going to come back down to 0. then go below that, and then it's going to come back again.
Okay.
Because later on I'm going to ask you, what's the solutions? What I want to do is I'm going to say, what are the solutions for this function? That's where we're really going. And I can give you any function I want to, even ones that don't turn out nicely. I need you to be able to kind of figure it out based on what information you have. Okay? And we're going to spend this whole chapter kind of figuring out ways to make this solve this, even when it goes ugly and sideways, or x to the 4th. We've got weird stuff going on. But again, we're just kind of opening the beginning of this mess. Yes, ma'am.
For -2, is that the actual word?
Is that the actual maximum you mean?
Yeah.
It may not be. Maybe very slanty. You know what you could do if you really want to? What would you do? Get out your graphing calculator, hit equals, and graph it for you. Do the whole thing for you. What if I said the following, Chris? I said if the roots are 0, -5, and 3. What polynomial gave us that? Walker? Shh. This one did, but how did we get there? Look at this right here. Right? To get a 3, we have x minus 3, right? To get a -5, we have x minus -5, right? Which is x plus 5. And to get a 0, we have x minus 0, right? So that's how they do it. So what if I gave you roots? I said the roots are 0, √2i, and -√2i. How do I figure this out? I'm simply going to go like this. I'm going to go x minus 0, x minus √2i, x minus -√2i. And that's equal to y. Now what? Simplify, right? Boil it all together. So I'll start with this. I go x. This becomes x minus √2i times x plus √2i. Now I'll give you a huge hint. The imaginary ones should cancel out because usually the function is not imaginary, right? So i's got to go away. So what two should I multiply together first? The two imaginary ones, right? Because it's going to make the I go away. Has to, hopefully. Okay, so what am I going to do? First outers, inners, last. You know how to do this. First, what's x times x? X squared. Outers, x times √2i. √2ix. Looking bad. Inners, -√2ix. That feels much better all of a sudden. Chris, are you good? And then -√2i times √2i. √2 times √2 is 2. So this becomes -2i squared. Is everybody good? Okay, so then I'm going to simplify. This is x squared. That goes away, right? What's I squared? -1, negative, this becomes +2, right? And then distribute the x through. X cubed plus 2x equals y, and I am done. Okay, so that would be the function of least degree. Why does it say of least degree, by the way? What if I just added another factor? Could I add another factor? We still have roots here. Yeah, I can add any number of factors I want to. Let's not do that. Let's just do the least degree. This was enough fun. Fair enough? Don't say good?
Yeah.
Okay, if you're good, try the next problem. Try number 7. Let's see how we do.